I thank you all for your participation, the ones that are here, and the others that are attending online. And we recognize, of course, also the history of nautical cartography, for the understanding of what really is Medea-Chart, and I wish a very fruitful conference. Thank you. Now I am the floor to Professor Gaspar.
Thank you very much, Admiral Marreiros. I see very well-known faces, but some of you may not know me. My name is Joaquim Gaspar. I'm a retired captain of the Portuguese Navy. We engaged in a new career of investigator on historical cartographic subjects. Once again, welcome to the second workshop on the origin and evolution of the nautical chart. Thank you very much, Admiral Marreiros, for your warm words and introduction, and also for your generosity of offering once more our workshop. As you said, this is for sure the best possible place to hold our meeting. Those who also participated in the 2018 workshop will recall the flawless organization and how well we were received in these same facilities. Also, many thanks to all participants, especially to those who left the comfort of their desks and decided to come in person to this event, some from distant shores. Taking the risk of not considering online participation was deliberate, as we were well aware how the recent pandemics has left marks on people's behavior in terms of traveling and gathering in presential meetings. Only yesterday have we passed the information that the event will be recorded and streamed via YouTube in real time, as it is being done now. Some of you may be perplexed by the name given to this meeting, second workshop, since this is in fact the fourth event of the series that started back in 2016. The reason is that while the first two were explicitly focused on the medieval portolan charts, the scope of the following meetings was enlarged as to also consider nautical charts of all periods and origins. That is why we now have such a diversity of themes which address not only the medieval and early modern European nautical charts, but also such novel and exciting subjects as the Renaissance of Japanese cartography, the incorporation of longitude readings on 16th century charts, and the 19th century printing techniques. As you know from the program, this will be also the time for sharing with you some of the results of the Medea-Chart project, which will be officially closed by the end of the present month. That will be the subject of tomorrow's last session, where we also aim to get the feeling of you all about its impact in our small community of historians, and how its legacy may be projected into the near future. One of the program's outcomes of the project was the organization of a public exhibition mostly focused on the method of construction and use of old nautical charts, as revealed by modern techniques of geometrical analysis and physical examination. That exhibition, with the name "What is a Nautical Chart Really?" was launched last week here at the cartographic office and is now open.
Please use your free time during the lunch and coffee breaks to go there. A visit is planned tomorrow at the end of session 7, when the creators of the exhibition, which are the Medea-Chart team, will be available for guiding you. A flyer with a summary of its contents is included in the workshop documentation. Finally, here are 2 useful links for the book of abstracts, which we decided not to print on paper, and also for the Medea-Chart database, which most of you already know. I believe most of you have a QR reader in your phones. I just became aware of such things, well, a few weeks ago, but I am an old guy, you know. Okay. Thank you. I will now pass the word to Ana Margarida. Where is she? She's not here. She's outside. Okay. Our project manager and communications officer, who will give some logistic information. I think we are well ahead of time. After Ana Margarida talk, which will take, I don't know, a few minutes, we may have a short break so that the people who didn't come may have the opportunity to come and join us. Ana, the floor is yours.
I have nothing to say.
Okay, yes, you do. Just recalling what you have said to the people. Okay.
So you all know me by now, I think, by all the emails we have exchanged. If you need anything, I'm here to help. So please let me know. Thank you all again.
Okay, about the lunch, about the places.
Yes, I've spoken with everybody. Each one of you already knows. So lunch is upstairs at the cafeteria. You have to pay at the end after you are served. And then dinner, it will be Friday. And I'm already collecting the money for the dinner. And other than that, I guess it's just a very welcome.
Where's the coffee?
Coffee break is also upstairs at
Upstairs.
yes, at cafeteria. Just follow us. And there will be some books on sale from Publico. We have this outreach activity throughout the project, that each week a new article was published on the local newspaper. If you want to buy the book as well, it will be available as soon as possible, because I'm waiting for the Publico to just send us the books. And yeah, I guess that's all. Sorry. I'm afraid of that. Public speaking.
Anyway, let's make a short break and be here a little before 10 to start the first section. Thank you very much.
Souvent, il faut appuyer sur une touche.
En général, c'est juste ça. Hein. C'est juste la petite flèche.
Celle-là.
Oui, oui, oui.
Parce que je ne sais jamais laquelle c'est.
Hop, hop. Non, c'est bon. To help us.
Only
Can you
one,
help?
please.
Thank you.
Only one view
Voilà.
on the screen.
Just one view because it's a PDF.
Just
Ah,
one.
okay, full screen,
Yes,
right?
full screen. Exactly.
Okay, okay. Let me see.
This is a PDF, but it's opening on the web browser, so I will try to do something else. Okay, I will have to call our guy from informatics and computers, because we don't have the software to run this.
Full image.
Yeah. I will ask him to install something to read this independently, not from the browser. So then you can put it on full screen and run smoothly.
Je vais juste rester là.
Sorry? Oh, you're not on yet. Hello? Sorry to sorry to interrupt the discussion. There's going to be plenty of time for this during this workshop, and we want to start promptly and give a good example to those who follow about keeping the thing on time. So I'm not going to read out anything of Jacques' impressive CV, and you've got access to it by in print, as I did, or by being clever with your with the QR and so on. And nor am I going to have to give you the title, because there it is. Whether it's last views news is actually the correct title, or whether perhaps it's latest. We'll wait to see which it means. So I invite Jacques Mille now to come up here to deliver his paper. Thank you, Jacques.
Thank you. Thank you. You may shadow. Hi, good morning, everyone. Okay, that good? Okay, well. Yes, good morning, everybody. I am glad to be the first to talk for the stake in the workshop. The first time I speak here since 2016, and in this space of time, I have made research on the Avignon chart, and in 2021 I published a book. You may see it at the back on the subject. This chart is now well referenced in the first nautical charts nearby the unsigned, undated Pisan, Cortona, and Lucca, and of course of the Vescons one, which are 2010, 11, 7. Its major interest is in the fact it's the first to represent circa 2003 and 10. Obviously, in the schematic and strange drawing, the northern regions with the Baltic Sea and Gotland, almost 50 years before the charts of Carignano and Medea-Chart. Yes, you have the text I am reading, and okay, here you are the chart and the main data, main reference points you may see, especially two grids, one for the North Sea, one for the Adriatic Sea, and all points, spots which are referenced with cities, ports, as London, Sevilla, Marseille, etc., Gerba, and inside Bremen, Venice, as well as the Barrier or Algiers, this area. And you may see on the chart, the chart is very damaged, cut, torn, holes, broads. There is a very, very poor chart, not very spectacular. But it presents many interests to study. Especially you have on the top a long named river, very curious, and which pose a problem, and as well the coast, which are in the North Sea, east of the North Sea, which are not European coast classical, but a curious drawing. We much make an explication. I shall try to do it sometime. The major interest of the chart, as you understand, I speak very bad in English. So I have allowed the time. I have made a booklet in which I summarize the essential of my views and conclusions on this chart, and you may find it back of the room, where the essentials of my views and conclusions on the chart until this year. And then I have reduced today my purpose to 4 points. First, scales, coordinates, religious background, and making of the chart. The booklet is free of charge, and you may keep it for you. These 4 points are the following, on which you may have an eye, because I just overviewed before. The discovery of two different scales, the possibility that the chart maker may have knowledge of the latitude and have used them, the possibility to link them with clerks due an hypothesis about the double toponymy paradis in England, very curious. At least the problem of the drawing of the chart by a medieval chart marker against the thesis of Nicolai and Tome Marelic, who will speak just after me. But before the presentation of these 4 points, I think it will be of use to you or mine some essential data acquired at the beginning of 2023. They are in my book and have been said in the video conference, some uncertainties, other more or less believable hypotheses. For certainties, the correct representation from a common fund of the Western Mediterranean Sea, also broadly tilted towards southwest to clear space at the top of the parchment, thus allowing the drawing of the northern regions. Same thing for the French Atlantic coast and Brittany, better than Pisan but lesser than Viscount, maybe a linear progress, as those of Great Britain up to Scottish Firth, and the drawing of Western Channel or the Severn, making possible an hypothesis of a circumnavigation. Other certainty, the chart maker was an expert to follow the project's view. I have to give his remind for you, all of you. He could not came here, luck. To follow through the view, master in cartography as proven by drawing itself, his calligraphy, his technical means, different scales, specific semiology for mouth of river or the Danish bells, as you may see down of the image. And of course, the solution he has found to show in the same grid the coast of Great Britain facing those of the Northern Europe, in the reality very differently oriented. You have on the screen some reference points and question about the drawing of this strange North Sea, right north, but if coast of England are very well represented, it's the direction, the orientation of the coast, eastern coast are very curious, but you may see and follow from Netherlands, the Zuiderzee, the Frisian Island, the Dollard, the Jade, the Weser, the Gitzland, the Elba, the Cape Skagen, maybe the bells of the Danish bells, and top the north with a strange word, it's not my subject, maybe the Vistula or a curious river you see some time ago. Also certainty, the long unnamed river, surely not the Elbe, but rather Oder or Vistula, if not a strong probability, a synthetic river to show the link between the Baltic Sea and the Black Sea through the Russo-Ukrainian rivers, which is known as a historical trade route. And of course, a strong probability for the drawing of the island Irlander, which is an apex, maybe Gotland, if you look at the reality, and probably not a mere coincidence. And the dating, of course, beginning of the 14th century. At this end of this short overview, the remaining problems and some news. What remains unsolved, there are the writings on the chart and its back. They have been undecipherable until today. They are contemporary with the chart because they're covered by the wine lines. That's in fact a big problem. And research by paleographers are in process with uncertainty of their dating and origin, and no one was able to translate them except one or two words and not sure. My assumptions are about the dating, and what about a carbon-14 analysis? Not possible. The rose flower with 24 petals may be a navigational clock, but surely an hypothesis, mere hypothesis. And is the so exact drawing of Gotland due to a Hanseatic source or a Mediterranean mariner merchant came here? Maybe an hypothesis. And now the precise subject of this presentation announced before. First, there are two scales on the chart, not visible at the first glance. At the top, northern scale, very well represented, drawn, which is in the grid and represents the coast from Bruges to Gotland, Courland, or region of Riga, with reduction in the red sign seen inside. You may see at right. And just at the back of the chart, a part of a scale, very, very light, little, and it is in fact a representation for the scale of the whole chart. Yes, you may see the most visible one, top of the chart, with two red circles complete with a red sign seeming to be an island, which is impossible. And the second in the bottom right corner, of which only a little part can be seen, but we can redraw. And after being redrawn, three circles, two red, one green, and it appears larger than the previous. There are the circle are only views on Pisan and maybe Cortona. Vescons, it's more difficult to interpret. In fact, we are here a scale for the whole chart, and it is a new unique case among the nautical chart for the formative period. Here we have the proof of a specific scale, the northern one, for the drawing of the long coast from Bruges to Courland, facing the British ones, and the testimony of the mastery of the chart maker, who has made a reduction of scales and explained in this way the red seen in the circle. In fact, Gotland reduced. This gives us a clue for reading. And this is not, as I thought first, Praga or the quadrilateral Bohemian. And second part, a look on latitudes and longitudes. It is an approach not geodesic but basic, but I think sufficient to demonstrate three facts. First, they use in the western Mediterranean part of the chart. Two, the well-known inclination west of the meridians, about 8 degrees, maybe the magnetic declination and the use of the compass. Third, the important tilt toward southwest, for all which is in the western part of the chart, but still visible thanks to the positions of the toponym on the French Atlantic coast and in Great Britain. And I spend for today to make space at the north of the parchment. And you may see with meridians and parallels the correspondence with the reality. It's known that geodesic coordinates were new in the Middle Age, and from the start I have looked at the latitude and longitude of many places and saw huge distortions, such as Marseille facing Cherbourg or Hull facing Venice. But on the other hand, London and Valence and Oran are located correctly on the same meridian. Hence the first conclusion, no use of geodesic coordinates to draw the chart, but certainly there's knowledge. And there are some clues leading us to think the chart maker was well aware about them. First, correct latitude. You may see correct latitude and longitude in the Western Mediterranean Sea, in spite of an important tilt because of the necessity for him to save place, as I said, at the top of the parchment to draw northern regions, which is the real purpose of the chart. And second, hence the distortion quoted above, but strange enough, second, we have also correct latitude in the northern regions. If it's important, we look at them after a constitution and a tilt of 19 degrees, as we may see here, and you constate Aberdeen, Capskagen, Gotland are on the same latitude, same parallel, and Spurnhead, Bremen, Lübeck on the same also. For longitude, the correlation is not so clear, particularly with an aberration between Bremen and Lübeck, 2 degrees in reality, which may explain by a drawing made from nautical distance sailed round Denmark and not geographical distance. First, for geographical distance, there are some 100 kilometers. From nautical distance, there are about 100 kilometers and many days of navigation. We know the geographical coordinates were known in the Middle Age through the Ptolemy's legacy, les tables d'Alfontine, Paolo della Bacco, but they were not used for navigation and maps. We then have a probability that the chart maker knew the coordinates, but did not use them to draw the chart, apart from placing some spot correctly, as in the north, on the lines of the grid. As Spurnhead, Bremen, Lübeck, Scotland, Skagen, Gotland, perhaps quite by chance, but nevertheless disturbing. As disturbing, the drawing of church and the double paradise in England, as you may see here. And churches are very rare on the chart, nautical chart. Also disturbing is the case of the 7 churches the chart maker meticulously drawn with many colors on his chart. Here is an enigma because it is impossible to find what place is noted. A church in a city may be Cologne, or a monastery, Münster, or pilgrimage churches. Some are possible and only hypotheses, but why not, for example, Mont Saint-Michel? Nevertheless, it testifies the religious background of the person who had ordered the chart, or the chart maker himself, a clerk, a monk, we don't know. And in fine, a marvelous unicum. Even if Ramon Pujad has detected a light drawing of a church very different and not colored on the Vescon's map of 111. Because of the church and the religious background, we are led to consider the double toponym Paradis, written in England, was in red. In spite of many research by Catherine Delado-Smith and others, no actual correspondence has yet been found, and we must only suggest the most reasonable explanation, as she says. It is known that there were many monasteries in the region of the Fens where the 2 toponyms are written. Perhaps the chart maker, rather than to draw several churches, the drawing could have written this double paradise linked with monasteries which often the past called Paradise Row, and through these suggested their great number. Of course, just an hypothesis before a future and accurate interpretation, only a hope. At least, and to conclude, we may admit that the Avignon chart is very important for the knowledge of the first nautical chart and their study. In spite of the uncertainty about its dating, but certainly at the beginning of the 14th century, probably before Vescon's first maps, Ricardana charts of 111-13, and that it was drawn from own original source. I precise own original source. Common Fund for Mediterranean Sea, surveys for French Atlantic coast and Great Britain, hearsay for northern coast from Hanseatic sailors or merchants, and see Brie, for example, written in Old Norse and not Bruges as on all other charts. But also the mystery of the author of the realistic drawing of Gotland, revealing a good and direct knowledge of the island. And also conclude with the certainty that the chartmaker was a professional, able to use his own knowledge and other contributions, making them in chart with technique of the time, and also able to innovate. In fact, certainly able to draw a draft from sole data given by distance and wind direction, as those given in the Compasso, for example, and complete them by his direct knowledge of the coast to refine the rough lines of the initial draft. But only in the Mediterranean area, because at this time there is no portolan for the Atlantic and the northern region coast. So, to end this talk, just these following views to affirm my conviction that the medieval chart makers were well able to draw a map based on their own knowledge and their own know-how. Here, an attempt to show the possibility, if not an absolute proof of a link between portolanos and data chart. In red, you may see the lines given from the compass according distance and wind directions. In green, the lines from the Liber, which is not so precise in this way, but only on the in the Mediterranean area, in this space, little space of the Mediterranean Sea, and the controversy, which first, the portolan text or the map. In fact, the problem of the hen and the egg, as you know. And here, the report on a actual view, as you may see, the possibility to find the correspondence with the lines obtained with drawn from Compasso and the reality of the geography with the coast and the islands of Tangiers. To end, some views of the first nautical chart with a glance on Barents Mouth. At left, Pisan. In the part in yellow, you have the island near Marseille. At right, the Avignon chart. Down, Vescont. And to insert with the Barents maps, one of Mediterranean Sea, one of Provençal coasts. And drawing for all from a common fund, according to the mastery of the each maker to their own use and that of data, then differences, and it seemed Vescont's best result, even if Pisan is already very close to the reality. I have not used complicated tools, computer out of my competence, but only a practical method as Jonathan Landman did, giving the results which we have and which really surprise us with nearby the reality. For Barents-Chart, it seems he has used coordinates, it seems, and Mercator's projection, but in fact, it also seems he's always following the Westcon pattern and not use coordinates. Perhaps a geodesic study, as made by Tome Marelic for the Adriatic Sea, could bring some glimmer on this point for the future. But on the other hand, and more simply, I think the best argument to admit the medieval chart makers were able to draw them up from sold data of distances and wind direction, plus draft from mariners and their own knowledge of the coast for some ones, lies in the drawing of the extra-Mediterranean coast beyond the Strait of Gibraltar, African and European coast, of which no previous maps could have existed, came from old times, and then drawing well made by those medieval chart makers supposedly unable to realize such correct maps. But just here my personal conviction, admitting all supported remarks, and in this way the mean to enrich the discussion and who knows, to reach the truth one day. To conclude, at the end of 6 years research on the Avignon chart, with classical means, I may draw up an assessment, many certainties, but also many proposals which could be discussed, and some unsolved problems I leave others cherchers. Perhaps some of them will be solved by modern techniques, the writing, for example, or the dating of the vellum. But some details will remain always more or less believable hypotheses, such as churches and the flower with 24 petals. So the Avignon chart keeps a part of mystery about its origin, as the Pisan, Cortona and Lucca, the 4 original, anonymous, undated and deviant charts Peugeots include in a little black crosses family, and Campbell in the formative period. Before, or perhaps at the same time, Westcon charts are becoming the impassable model for a long time. That's all, folk. Good luck to the future session, and thanks for your attention.
Thank you very much indeed, Jacques. You didn't disappoint us. These for the 4 of these workshops, I think have all of them been enlivened by the growing and developing theories that you have about this single and very interesting, and I'm slightly glad to think still not completely understood. I think we do need to leave something for our successors. Now, I'm sure that you touched on a lot of different aspects, and I imagine that there will be a number of questions that will emerge on that. So can I, from Joaquim, yes.
Maybe I'll come here, otherwise people won't hear. Well, I have a lot of questions. Maybe I'll make just 1 or 2 and pass the word to other people. Just a short note about the dating of the chart. A couple of years ago, more than a couple of years ago, Tony and I were talking about the BNF in order to analyze with hyperspectral imaging and also radiocarbon dating some French charts. One of them was a Partizan, which was analyzed, but not the others. What happened? Did the process stop? Well, a short question. Let me.
Well,
okay.
Just to say that, I mean, I don't know whether Emmanuel has any thoughts on that one. I mean,
yes, I'm aware of the problem because I'm not from the BNF staff. I'm from the CNRS, but I work a lot with Catherine Hoffman, who is in charge of the Campbell department, and actually they couldn't make it. results, but partial. It was not enough material to make a correct analysis. And for Avignon cards, it's because of the Avignon archives that never replied. So it's very, very slow process to make people react to scientists' asks. So that's just what I can say. They asked, they made the demand, but the Avignon archives never replied. So that's all that I can say. But maybe it will be a project.
Well, perhaps this meeting ought to sign a petition to Avignon Archive asking them to release it for that purpose.
Just two short comments. One about the relationship between nautical charts and rutters in the medieval period. I think it is accepted, it is a conceptual view nowadays that charts were not drawn from rutters. On the contrary, most researchers believe that rutters were compiled from nautical charts, and that is probably the case with the Avignon chart as well. I think it is conceptual now. It is the mainstream opinion as far as I know. Just another comment, and I will shut up about the lineage of this chart. In a very recent research that it is now under review for publications, I have identified for different lineages, at least two different lineages for the very first nautical chart. I'm not sure about the Avignon chart because just one small piece in the west is shown, so I could determine with accuracy what is the tilt of the chart. But maybe we can assign the Avignon chart to one of these two lineages. One very early, and maybe in the beginning of the, I don't know, 1200 and something, and the other late. And I will shut up. Thank you very much.
But the chart is a fantastic one because they pose many problems we are not able to give a solution. But we may do hypotheses because there is no other way. Like only suggesting a possibility, but not a certainty, not a proof, absolute proof.
Another hand would like to go up or not? Yes, I'm surprised. And yes, Chet, yes.
I was wondering if you could say a few more words about the purpose of the chart. I was wondering if you could say a little bit more about the purpose of the chart. You alluded to the fact that its purpose relates to the northern part of Europe.
Yes.
And maybe you could say a little more.
Certainty, the chart represents.
Yes, can you speak? Sorry, you speak out for the audience at the back.
The Norfolk coast, certainty. But the eastern part of the North Sea, of the strange North Sea, it's only an hypothesis. And we are obliged to tilt 19 degrees on the right to make the coast on the right line, the good orientation, and then we are surprised. There is the triangle, which is maybe Denmark, the Danish peninsula, and the long river, unnamed river, maybe the Vistula, and the island, maybe Gotland. If you look at the reality of actual map, mere coincidence, strange in fact. There is no other example on nautical charts of island except in Aegean Sea, but in Western Mediterranean of island so well represented. True. So mere coincidence. Maybe Segor, Berchen, Declare, I don't know. Has gone to Gotland, stayed in Gotland,
a lot of maybes, Jacques. But I wonder whether there's any other question, or I got myself. Yes, please.
Yeah, I do have a question. How does what kind of material was the chart? What kind of material, the parchment, was the chart made of, the paper itself? And how does that help us understand?
It's a parchment,
Yep.
It was impossible to analyze this with carbon 14 because the slide was big, the start was too little. And the allocation of the Avignon, don't want huge at the chart to make another study. Then the thing is a mistake, of course. The chart.
Can I come in back with one question, Jacques? Jacques, hello, Jacques, can you come back, please? We need you here at the microphone. My question, Jacques, is you talked about the chart maker having a good understanding of the coordinates and the longitude and latitude coordinates. I think that means presumably Ptolemy.
It's strange.
And have you in fact compared, if you like, the Ptolemaic thing? Because
no. I am not an expert in nautical charts. In fact,
well,
and it's too complicated for me to use computer to make geodesic analysis, and only the I see if I take the compass and I draw the coast following the compass, I may realize a chart, a draft.
Well, that was what John Lamond did.
And latitude and longitude, I don't know.
Yes. Well, I think it was surprising.
But there are coincidences. There are coincidences which are very strange. For example, for northern regions, if we look at Scotland, Cape Skagen, and Gotland, it's on the same meridian. Parallel.
Okay. I mean, that might have been chance.
It's un constat. À partir de là, from that, everybody can see what he wants.
Okay. Is there any last question? Otherwise, I think we will thank Jacques for, as expected, a stimulating talk. I'm sure the conversations will continue, in the coffee breaks and so on. So now, if our next speaker, Tome Marelic, will come up, and can we get this changed, please, to the? No, I mean, but we need the screen. We need your title up there.
I have two printed handouts.
Who is to deal with this, Joaquim? No, go on there, okay. Well, I was going to say that I don't have to say anything because it's on the screen, but it's coming up. Okay.
Just a second. How do I go? Is this?
No, you do it. Okay.
Here it is.
Okay. All right. Well, here we have your details, and looking forward to, from what I've read in the abstract, looking forward to another challenging paper. Over to you.
Okay.
Thank
you very much. Hi. Hello, everyone. It's Nice to be here. I'm Tome Marelic from the University of Zadar, Department of Geography. And I'll tell you something about the, well, I'll read it aloud, certain arguments against the hypothesis that portolan charts were genuine late medieval cartographic products. My presentation is like two-part presentation. One is about the late medieval and early modern manuscript portolan charts, let's say the real portolan charts. The second part is about the printed navigational charts, let's say the post-portolan era of charts. And I did some analysis of the contemporary geographic maps and the Ptolemy coordinates data. So maybe there will be some answers to the previous questions. There was no arrangement before, it's just coincidence. So my presentation is very dense content-wise, so I'll be like telling, I will skipping slides quite fast, and there will be some like, let's say, slideshows with fast forward and fast backward, so you can see some, let's say, chronological changes on the same picture, but on different slides with the same background. So this is the part one. There are 7 main topics that I've investigated, or let's say maybe some research results that came from it. So the first one is geometric best fit with modern map in projected and various selected map projections. The another one is the geometric similarities or dissimilarities to one another among charts. The third one is the determination or the inspection of their geometry in more depth on a sub-regional level of the Adriatic Sea. My work is mostly based on the Adriatic Sea. Their accuracy in accordance with their map scale or with the chart physical size. Their orientation, so was it contemporary magnetic north or geographic north? Their accuracy in accordance with terrestrial view shed from sailor's perspective in order to perform, let's say, terrestrial navigation. And the geometric similarities or dissimilarities to textual data contained in portolani. I've analyzed 5 rotors, 5 portolani, their bearings and distances. You'll see it later. This is the chart sample. I'll skip it. So this is like my basic framework for geometric analysis of charts. There are like 45 points and 80 lines. Let's say it's like a skeletization of chart, and the skeletization of the reference frame, the reference map in the selected map projection. So my results showed me that geometrically the shape of the Adriatic Sea fits best with its shape on the modern map projected in the Mercator projection. This is this line. All of those graphs should be read as the lower the value on the y-axis, the more accuracy the map shows. So the lesser the numbers, the larger the accuracy. So each of those 12 maps, and these are pair of maps produced by the same people, but on the different maps in the different map scales. Each of the 12 maps show best geometric fit to the modern Mercator map. Also, this is the x-axis accuracy. Also shows the best comparison with map projections on which the convergence of meridians is not displayed, which leads to conclusion that the supposed map projection that is like in the background of portolan charts should be some kind of cylindrical projection. The y-axis, which corresponds to longitudinal accuracy, but there are no longitudes and latitudes on maps, so this is just geometric shape. It fits best with the Mercator projection, which is important because on the Mercator projection there's like progressive increase of equal degree latitude intervals, unlike the, let's say, equidistant map on which the equal intervals are equally spaced along the whole map. These are the vectorized outlines of the Adriatic Sea on all those 12 charts. These are their designation. CP stands for Carta Pisan, Pietra Vesconte, Catalan Atlas, Andrea Bianco, Gratiosus Benicasa, Anonymous Chart, Battista Agnese, Diogo Homem, and Vincus Demetrius Voltius. They're made Adriatic in atlases. In one atlas, the Adriatic Sea was, the whole area was mapped in a smaller scale, but there are separate atlas sheets in atlas in which the Adriatic Sea was drawn in a larger scale. And the approximate map scale was 1,700,000. So this is the mathematic or geometric overlap of all of those 12 charts. Each chart was georeferenced upon 45 points, and this is the whole point cloud for the whole, let's say, system. So each of those, almost each of those, the Piston chart is the exception, shows that the Adriatic Sea was plotted like a bit wider towards the north west area, and it kind of shrinks or narrows more towards the southeast. It's like the same graphical pattern that occurs successively from chart to chart. This is the accuracy of the Northern Adriatic, which is like a lot wider than the rest of the Adriatic Sea. These are the coastal outlines of the oldest 6 charts from my sample. They are kind of similar to one another, but those, you see those ellipses, those are the standard deviation ellipses, doubled actually to see them a bit better. They are bigger for those older charts because they were not that much similar to one another. They were, but not that much as the later charts, which are becoming more and more similar, especially the latest charts from my sample, third made by Agnese, Homem, and Voltius, which are almost nearly the identical copies of one another. Their deviation ellipses between those 3 charts are very small, so they needed to be doubled to just to display them here, because if I put only one standard deviation, those ellipses would be invisible in certain occasions. So this is the chronological graph. This is the accuracy, graph of chart accuracy, which was like more or less static to the whole 300 years period of my research period. So their accuracy was not becoming greater nor worse. It was more or less stagnant throughout the time frame. However, their intersimilarity from one to another was becoming greater, so charts were becoming more and more similar to each other as the time passed. This is the overlap of 2 coastlines. One was the thin black line is from Vincus Demetrius Voltius, and the thicker red one is from Carta Catalana. They are like 200 years apart, and you can see that the outline of the Adriatic Sea is almost identical. Aesthetically not. There are some different on the micro level. There are some differences, but on general framework is very similar. 200 years passed from one to another. Also, the charts which were produced in the larger scale were actually not more accurate than the smaller scale charts, which means that if you use these charts hypothetically as the navigational aids, the errors on the larger charts are actually bigger, because the charts that were made in the larger map scale were actually the enlarged, seem to be at least enlarged copies of the previously made charts, which were made in a smaller map scale. However, those later made charts in larger scale seem to be more accurate on a local level. Some, let's say, bays or promontories were rendered more realistically, less sketchy. However, the whole geometrical framework was not geometrically improved. So these are those three charts, this dashed line. They're not any significantly accurate than these charts here. For example, the Catalan Atlas or Andrea Bianco's Atlas. Next, there is, let's say, an unaltered anti-clockwise tilt of the Adriatic Sea rendering. The charts do show better accuracy or higher accuracy in comparison with the contemporary magnetic north. So these magenta pink lines, they show better accuracy with the contemporary magnetic north. Those green lines show better alignment with the geographic north. And you can see there are also there are clusters of those areas which also go in favor with the conclusion that charts were copied from one another. But interesting thing is that in accordance with the paleomagnetic model which I used, this one, down in the brackets, according to it, the magnetic declination value for the Adriatic Sea was in decline during this 300 years. However, the tilt of the Adriatic Sea remained nearly the same regardless of the real situation, the real dynamics. However, these charts here are interesting, at least for the Adriatic Sea, because it is possible that some knowledge happened in this area. Maybe someone noticed that navigation-wise it would be better to tilt the whole area anti-clockwise in this. However, it calls for additional investigation. Also, there is something which I labeled the terrain invisibility paradox. This is the detailed viewshed analysis of the Adriatic Sea for like 17 buffers of distance from the coastline. I've simulated here the eye height of the sailor at 20 meters. It corresponds to a crow nest, to the altitude of the crow's nest on the ship. However, it's more like optimistic analysis because the compass was stationed at the deck at the stern of the ship. So it will be more like 7 or 8 meters for the sailor's eye height to compute into the analysis. This is the other part of the Adriatic Sea. And what is interesting is that my skeletal shape of the Adriatic Sea, those lines here, the most accurate, bearing-wise, the most accurate subset of these lines are cross-basin lines, especially this cluster here in its southeastern part. But what's important here is that when sailor sailed from one shore to another, when he starts from somewhere here, like let's say Bari or Brindisi, he's not able to pinpoint any coastal object on the opposite shore because of the Earth's curvature. He cannot see where he's sailing at, so he cannot aim the compass to a certain point and follow that path. But this region, when measured in a cross basin, when approached in a cross basin manner, shows the greatest accuracy. So the bearing accuracy between these cross basin points is higher than the bearings between the points along the same coast. This is the graph of the bearings. So these are, we can see here that the most accurate subset of lines, bearing-wise, was the cross-basin lines. It's interesting because in the 19th century, when the hydrographic survey of the Adriatic Sea was performed, it was a joint operation, Austrian and Italian officers. The only possible way or path or area through which they were able to stretch the geodetic network across the Adriatic Sea was this area here, between the Gargano Cape and this Cape Plotcha, and across this cluster of islands. However, bearing-wise, or angle-wise, this is the worst case scenario on the portolan charts of this area. So these islands around here are scattered almost, let's say, it's impossible to determine any pattern of drawing those islands around. Okay. This is the well, visualization of the navigational paths which are extracted from these 5 Portolano documents: Liber de Existentia, Compasso da Navigare, Pietro Versis Portolano, Parma Magliabecci, and Riso Portolan. Here is the amount of the total navigational paths, the coastal paths, and the cross-basin paths. And what is interesting here, and goes into favor that charts came first, then the texts were extracted, from the charts and scaled into like real-world distances, is that the shortest paths, and especially the coastal paths of that are very short in length, they are the most unstable data in terms of the portolan mile value. So this is in general, the rule of the thumb, let's say, is the shorter the path is, the more chaotic its portolan mile value becomes. Okay, so the longest possible paths, and those blue ones are cross-basin lines from Portolani. Their portolan mile value is, let's say, the most constant or closest to their regression line. Less deviations. The longer the line, the deviations are smaller. This is table view of the same thing. So according to my results, the problem why I believe that the charts were not the original late medieval discovery in terms of the data survey, the physical charts were drawn in that era. It's like it's beyond any say discussion. The problem is that they emerged suddenly in very accurate form, and that they were not becoming more and more accurate. They were just becoming more and more similar to one another. Also, the Portolani data, which is logical at first to assume that there were some kind of data logs during the navigation. So they appear to be extracted from maps. Not it was highly unlikely that those data logs were recorded first, and then someone sat down and transferred them into the graphic product called the portolan charts. The part 2 is the early modern age nautical charts with reticules. This part is more rich with images. I call it post-portolan chart era, and I'll tell you why. I've analyzed also their geometric fit with certain map projections of the modern map of the Adriatics, and also analyzed their longitude and latitudes. And in parallel, I've analyzed some geographical maps made or produced in same period, and tested the accuracy of their coordinates and the accuracy of Ptolemy's coordinates. This is the map sample. This is the chronological flow, let's say, of the results. The blue line is the geometric fit with or the results in comparison with Mercator projection, and the orange one is it's called SILE 36. It's the normal equidistant cylindrical projection with latitude 36 used as the standard parallel. It's also known as the projection of Marinus of Tyre. It was known since the antiquity. This is the Vinces Demetrius Voltius portolan chart. There are some overlaps those three charts were also included in the part 1. This cluster are new charts, and those in these rectangles, they contain reticule. Those here don't. This is Willem Barent's printed chart 2 years after this one was hand drawn, and this is Robert Dudley's composite, free chart composite of the Adriatic Sea. Someone here will talk about Robert Dudley later. Okay, so there are some unintentional overlaps here. Maybe it's a great thing. So this is the accuracy of Claudius Ptolemy's coordinates data set for the Adriatic Sea. I've made the longitude shift of 25.2 because of the prime meridian. It's different. And you can see the huge longitudinal errors here and huge latitudinal errors here. And the whole data set is especially longitude-wise quite scrambled in comparison with the real coordinates of those locations. This is the comparison of Ptolemy's data set with 3 geographical maps. You can see them down there. 1570 Gastaldi's map, French map from Pierre Duval, 1664, and Vincenzo Maria Coronelli's map from 1688. This is Duval's map, so it's like more visually attractive. Here you can see the similar pattern of longitudinal errors here and here. The blue part of the image is the modern map of the Adriatic Sea. The similar pattern occurred later, 2 decades later, on the Coronelli's map. This is geographical map, and this positioning of the map above the modern map was done by extracting the coordinates of those maps and plotting them as GIS point data sets. So this is a product of computation, GIS computation. Nothing was done like in freehand manner or something. This is the different view of it. So these are the coastal outlines of geographical maps, and we can see clearly that there is still an exaggerated Ptolemy's footprint, let's say, in the shape of the Adriatic Sea. But the contemporary navigational charts, which will be shown in the next slide, and the image is aligned longitude-wise, so the meridians are vertical to one another. We can see the completely different shape of the Adriatic Sea. Those 3 renders of the coastline vectorized were also generated from the coordinates extracted directly from map. So the data set of longitudes was completely different between those 2, let's say, cartographic realms. Let's say the geographical cartography still relied very heavily on Ptolemy's legacy of coordinates, while the nautical cartography had completely different approach to longitudes. Interestingly, the nautical charts of the Adriatic Sea are less accurate latitude-wise than the geographical maps. And they're also less accurate latitude-wise than longitude-wise within the charts themselves. So their longitudinal accuracy is greater than their latitudinal accuracy. It also works for the portolan charts in a graphical manner because they don't have the latitudes and longitudes. This is the comparison of 2, let's say, outlines from the same chart. One is generated upon the extracted coordinates, the black one, and the blue one is a purely graphic georeferencing, and they yield nearly the same result. Interestingly, for example, this chart is quite interesting. It's made by Pieter van der A, the Dutch cartographer, in 1700. He was drawing a nautical chart. However, he did not made it in Mercator projection. He used normal equidistant cylindrical projection with latitude 36 as standard parallel, the Marinus of Tyre projection, which is not conformal, so it's not applicable navigation-wise because the straight lines on this map do not correspond to loxodromes on the Earth's surface. And this is the comparison of 3 portolan charts, coastal outlines, and this is the 4 outlines of the nearly like decades or maybe 100 years after produced printed nautical charts. And we do this, we can see that the shape of the Adriatic Sea was more accurate on handwritten manuscript portolan charts, which do not contain graticules, than on the printed navigational charts, which do contain graticules and were made later. Also, these are the 3 charts of the Adriatic Sea, nautical charts made by the same person, Jacques Mille. He was the chief cartographer of the French Hydrographic Institute at the time. The first one was made 1737, then 1745, then 1771, and this is their overlap. So we can see that the chief cartographer of the French chief cartographer could not agree with himself how does the Adriatic Sea actually looks like. And what is also interesting here, all 3 charts were supposed to be the navigational charts. This one and this one, they were deliberately made in the Mercator projection, and the cartometric analysis proves it, confirms it. But this one made the middle, the second one, was on purpose made in the projection of Mariners of Tyre, which is not conformal, so it cannot be used for navigational purposes. However, the title of the chart is also that it's a nautical chart. So he produced a nautical chart which is not applicable navigation-wise. So the summary of conclusions from this second part is that I will read it loudly, maybe it's the easiest way. Spherical coordinates data of graticle-equipped nautical chart showed that their latitudinal accuracy is poorer than their longitudinal accuracy, which is like paradoxical, it should be otherwise. This phenomenon corresponds to geometrical properties of their coastline renderings, or its coastal renderings of the Adriatic Sea, as it is displayed on portolan charts, manuscript portolan charts, which preceded them and which do not contain graticules. And in parallel with that, the early modern age, the geographical cartography was highly influenced by Ptolemy, his data set of coordinates. However, they made their maps more accurate than Ptolemy's data set. Maybe they were comparing their Ptolemy's extremely stretched longitudes to nautical charts in which like the longitude-wise display of the area was more compact. Maybe they were searching for some kind of optimal graphic blend. But in general, regarding the nautical charts, it appears that in the era ahead of systematic hydrographic surveys, the authors, the cartographers who created those nautical charts, the printed ones, had no other choice but to partially copy the inherited, let's say, portolan charts framework, the visual footprint of the Adriatic Sea, as a reference model, and to implement certain localized trial and error modification with higher or lesser success. Okay, and that's it.
Thank you very much indeed. I'm fairly confident that there are going to be some questions. Obviously, there are many of us who are not perhaps fully able to understand the mathematical approaches.
I'm willing to explain it.
Well, and some of us have difficulty when somebody explains it to us as well. But I think there were a number of very interesting conclusions and some sort of surprising ones about the fact that the longitude seemed to be not as distorted as as sometimes the latitudes and also the nearest, the sort of shortest distances on the portolani would tending to be less accurate than the longer ones.
They're very scrambled.
They're scrambled.
Yes.
Okay.
The shorter paths are the scrambled data.
Okay.
Yeah.
All right. Maybe we'll get you to explain scrambled data later on. Can we see any hands rising? Yes, Greg.
Yes, I'm a loud American. I don't think I need to. Oh, thank you. So you want to understand, you showed 3 17th century charts that followed Ptolemy's outline for the
geographical
Adriatic.
maps.
I'm sorry?
Those are geographical maps,
Yes.
which were produced in parallel with some of the nautical charts
Right.
I researched. Yeah.
Well, it's just that if I had ever thought about it, I would have thought that the navigational charts would have been appropriated by the geographical map makers to use rather than they relying upon, a 15th century atlas they saw. I mean, could you make any comments about that? I'm kind of surprised that Ptolemy is still being copied, if you will, in the 17th century.
The legacy of Ptolemy, after his rediscovery, after the scholars from the east, from the Constantinople came into the Florence, and when the Renaissance era started, Ptolemy was like for decades and decades considered as the highest possible top-notch geographical authority. Well, you're aware that let's say the nautical chart aesthetics and some of the, let's call them tools, like linear scale bars, rhomb lines, compass roses and everything, they still dripped into the printed charts nearly the 19th centuries. So let's say that some kind of nautical chart matrix existed for like 8 centuries or something like that. The Ptolemy came into the Western Europe like century and a half after, and you're aware that there it was like a separate data flow or flow of events that happened in parallel with the nautical cartography. Maybe there were some mingling between them. I've just started to research the possible connections between the nautical cartography and the geographical map cartography from the, in my case, from the almost purely from the geometric perspective. And I've noticed that the pure Ptolemaic maps, you can spot them easily because there are extreme distortions of the area longitude-wise. There aren't that many islands. Ptolemy's data is very poor on the coastal parts, especially the islands. For example, for the Adriatic Sea, in Ptolemy's data, at least for, let's say, for a Croatian part, which has like more than 1,000 islands, Ptolemy mentions only 4, and one of them is not an island. It's a port which is like, it's a small town in the mouth of the river, like 10, 15 kilometers from the sea, and Ptolemy mentions it as a separate island. It's not an island at all, so his data is very inaccurate. But you can see that it also leaked or dripped into, like in a parallel scenario, which happened more or less. So those two, let's say, cartographic realms existed like in parallel without too much touching each other, at least according to my current level of knowledge. But for example, just a second. I haven't rendered islands here, but for example, this one, Coronelli's map of the area, the Adriatic Sea and Italy and the Tyrrhenian Sea and a bit of the hinterland here. Just a second, maybe I will. No, maybe it will work better. It's like geography data wise, it has a lore of the information contained in here, and interestingly, there are some locations on this map which have double labels. There are Italian labels and the Hellenistic Greek labels next to them. So, for example, it's not visible here. Dures, in Albania, it's Dyrrhachium, but it also has the Hellenistic name on it. The Cape Luca also, like there are 10 or 12 places around here which have double annotations next to them. Also, this part here is called the archipelago of Diomedes, which is the Greek name of it. The Tramiti Island are labeled the Diomedes archipelago. So yeah, there are strong Ptolemaic influences on the geographical map scene, but not that much or not at all on the nautical charts. But there's one interesting testimony, authentic historical testimony from 1464, Benedetto Kotrugli. He's from Dubrovnik, Ragusa. In Croatia, his name is Benedikt Kotruljević. He said in mid-15th century, regarding the portolan charts in his book about the navigation, that they should thank Claudius Ptolemy for making the original map upon which they created a nautical chart. So it's very weird testimony, because nowadays we know that according to Ptolemy's data, accurate nautical chart cannot be made. Yeah, but he probably heard that from someone, wrote it down. It should be maybe investigated a bit deeper or something. I've bumped on it accidentally. I used his book because he also has one Portolani segment in it, but it was not much useful to me because there are no bearings, only distances, so I rejected it. But I found that testimony about whom he believed to be responsible for the initial making of the nautical charts of his era.
Thank you very much indeed. All right, well, yeah, if we got a little bit of time, a fairly short one.
Yes, thank you very much for your answer. And thank you very much for this presentation. I have just 3 remarks and questions. The first one is that you don't say that those cards were not made in Middle Ages. That's cool. That's interesting, because you just demonstrated that was not survey that was used.
The survey is the problem.
No, but
the drawing of the chart is
please, that everybody understand me. The question is that in Middle Ages they didn't make modern surveys. So you could demonstrate that. But it doesn't mean that it was not made in Middle Ages, of course. It was made with other tools. And that's the question. And the tools is made upon maritime experience and not modern calculation. That's the point. And I have 2 remarks about that in your very interesting presentation. First, you say that the precision is better for long distance than for shorter distance.
Yes.
So it's really amazing. And maybe it's because the time for crossing the Adriatic was better known in a long distance than for short stops between ports that were, for example, you had many things to do in coastal navigation, and you had you had problems, yes, exactly. But the crossing of the Adriatic was a main route that was almost all the same time. Maybe it's one hypothesis. And the third remark, very interesting, is that maps are more precise in longitude than in latitude. that you said?
Maps, no, geographical maps are not accurate longitude-wise. You can see it here. They are
No,
quite
you
Their
say
latitude is higher than the latitude accuracy of navigational charts.
yes.
So
You
this
said,
one
but
is more
portolan
accurate
cards are
than
yeah.
this one, latitude-wise.
Okay.
Okay.
So I was just wondering if the longitude, the errors are less in longitude because it's a narrow sea in longitude. Then, so the distances in longitude between two meridians are better known than the distances in latitude. That's just a
But
question.
I need to ask you a counter question. How would
Yes.
you determine the longitude?
Because of distance of navigation.
The measurements of latitudes were well known
No,
at
no.
that time. but-
Understand me, because of the crossing of the Adriatic Sea
Okay.
is quite short. You can calculate the longitude by the measurement of the time of navigation between 2 points.
You could do that also for the latitudes. These are not huge crosses.
Yes, that's a question.
And to additionally check it by the celestial
yes,
bodies.
yeah, that's true. That's
Yeah?
true. That's a question. But is it about the projection? So the Mercator projection gives some problems in latitudes. Maybe it's the problem.
The map projection problem is whole different set of.
Yes. Okay.
but-
But we can discuss it a bit later.
Yes.
I think there's a lot more to be said obviously here, but these meetings I think are one of the more important of the aspects of them is the coffee breaks.
Yes.
Where people, the real business, as it were, can take place. So thank you. I think we thank you once again for a very
No problem.
stimulating talk. We'll make way for coffee. Yeah. Thanks very much. Sorry.
I have some additional visual to Mr. Mille, if you want to. Just a second. I want to show you my recent research is going beyond the Adriatic Sea. I will just show him and the rest of you the part of the North Atlantic, the European part, if you can allow me. Just a slideshow. It's on Croatian. Yes. Okay. No problem. Sure. No problem.